Hello everyone. So today we will talk about some properties of expectation and variance. For example, we are going to derive the expectation of ax plus b is equal a expectation of x plus b, and then variance of ax plus b is equal a squared variance of x, where a and b are constants. So to prove that, let's assume if x is discrete random variable with sample space S and probability mass function PMF P of x. Now let's start with E expectation of ax plus b, which is equal, according to the definition of expectation, it is just ax plus b p of x. Now we just have to multiply p of x by a of x and p of x times b. So that will be sum of ax p of x plus sum of b p of x. And x belong to the sample space, and x here also belong to the sample space. Then, because a and b are constants, we can take them outside the summation. So it will be a summation x p of x plus b summation p of x, x to the sample space belong to the sample space, and the same thing here. So as we know, the sum of x p of x, that will be expectation of x from the definition of the expectation, and the sum of p of x, that will be for all the values of x, that would be give us 1. Now then this one equal a e of x plus b times 1, then that equal a expectation of x plus b. Therefore expectation of ax plus b equal a expectation of x plus a expectation of x plus b. Okay, all right. Now let's move to the second proof. So let's say the second one is variance of ax plus b, that equal a squared variance of x. Now let's first start assume like let e of x is equal theta. So we have the variance of ax plus b, the left hand side for this equation. So the variance of ax plus b, so that we can write that as expectation of ax plus b minus expectation of ax plus b, and all squared. Now we can write expectation ax plus b. Now the expectation goes to this part for expression, the first one and the second one, and then don't forget the the negative sign here. So that will be minus expectation of AX minus expectation of B, all squared. So that will be equal to AX plus B minus, because A is constant, we can take it outside the expectation. So it will be A expectation of X, and because expectation of the constant is constant by itself, then that will be B. Let's write something here like expectation of 4, that will be equal 4. This one is just example. Now we can, because we have minus B and B, that will be 0, and we have also E of X that equal theta, as we suppose above. Then expectation of AX minus A theta, all squared here, all squared, and then we can write this, because the A is common here in the expression, so will we take A out of the as a common from the expression here, so we're left with X minus theta and all squared. And this expression, this is the variance of AX plus B, and this one, because this one is squared, so we'll square everything inside the brackets, so that will be A squared X minus theta squared. And let's say a light note here, if we have like AX squared, then that will be A squared X squared. Okay, now as A is constant, we can take A squared outside the expectation. So we've got A squared expectation of X minus theta squared, and that expectation of theta of X minus theta all squared, that will be variance of X. Therefore, variance of AX plus B is equal A squared variance of X. And that's the end of the proof. I hope you enjoy the video. Thanks for watching.